Check it.
Okay, welcome back. Today we're going to be talking about how to solve equations that have radicals in them, okay? Cube roots, square roots, whatever kind of roots. But before we get into that, we have to talk about something called a multiplicative inverse. What is a multiplicative inverse? It sounds complicated. Well, multiplicative means multiplying. Inverse means the opposite, right? So what is the opposite of a number when you're talking about multiplication? Well, in mathematics, we define opposites as two things that cancel out, all right? So what does it mean to cancel out when you're multiplying? When you're multiplying, canceling out means that if you take one thing and multiply it by its inverse, its opposite, you will get a 1. And this is called the multiplicative identity, all right? So what would you multiply times 5 to get a 1? Well, the opposite of 5 would be dividing. Opposite of multiplying by 5 is dividing by 5. So 1 divided by 5. So 1/5. And this works for any number. So if you have a 3 and you want to turn it into a 1, which is the identity, you multiply by its multiplicative inverse, which is 1/3. Now, this does not work the same way for adding and subtracting. Adding and subtracting, the identity is not 1, it's 0. What's the opposite of 5 when you're adding and subtracting? -5. 5 plus -5 gives you 0. 3 plus -3 gives you 0. So when adding and subtracting, the identity, the thing that tells you that you've done the opposite thing, is 0, but in multiplying, it's a 1. So that's a little background. The important thing here is that you understand what a multiplicative inverse is, because that's what we're going to use for the lesson today. Multiplicative inverse is what would you multiply by a number to get a 1. So we already did this one. What would you multiply by? What's the a value that would, 5 times a gives you 1. What would a have to be? A would have to be the inverse of 5, and when you're multiplying, the inverse is simply the reciprocal, so 1/5. 5 times 1/5 gives you 1. Well, what's the multiplicative inverse of 1/3? What would you have to multiply by 1/3 to make it a 1? 3/1. Just flip it upside down. Of course, 3/1 becomes a 3. How about 3/4? What would you multiply by 3/4 to get a 1? 4/3. So finding a multiplicative inverse is really easy. Just take the reciprocal. How about -2/5? What's the multiplicative inverse of -2/5? Well, if you're going to get a 1, okay, because that's what you have to get when you're multiplying to prove that they're opposites. When you multiply them, you get a 1. Just like when you have a fraction 2x over 2y and you cancel these out. They cancel out because they become a 1, right? They don't really disappear. They become a 1. So when you multiply two inverses, you get a 1. And in order to get a positive 1, this negative has to go away. So whatever your a is, it better be negative. And then what will get rid of the 2/5? 5/2. So there you go. You flip the fraction upside down. If it's a whole number, then it's over 1. So flip it upside down, you get 1 over that number. And if it's negative, keep the negative. All right. So now that we know what a multiplicative inverse is, we're going to use that to solve equations that have radicals and fraction powers. Okay. Rational exponents and radicals. So we have 6 problems here that all need to be solved. They all have, the top 3 have rational exponents and the bottom 3 have radicals. And you can use this idea of multiplicative inverses to solve all of them. Okay, so that's why we did a little review there, or if you've never seen it before, that little lesson. Okay, so here's how this works. In order to solve, the word solve in algebra means to get x by itself, right? To get the variable by itself. So you just need to get rid of the power here. How do you get rid of this power? That's the question. If you can get rid of the power, you're done, right? That's it. You've solved for x. So, of course, you can't just cross them out like that. You have to actually do it algebraically. So how do I get rid of this 1/2 power here? Well, as long as you do the same thing to both sides of an equation, it's kosher. You can do that. It's legal. So I need to do something to both sides of the equation that will get rid of this power. Well, one of the things I can do to both sides is take another power. I can take both sides to the power of 5 if I want to, right? Because if this side is worth, I don't know, 2, and this side is worth 2, and I take them both to the same power, they'll both be, 2 to the 5th power, 2 to the 5th power. So, but 5 isn't going to do the trick here because 5 does not get rid of a 1/2. What does get rid of a 1/2 is the multiplicative inverse. So here's what you do. You want to get rid of the power of 1/2? You take this side to the power of the multiplicative inverse, 2/1. Flip it upside down and take it to that power. Now, to keep the equation balanced, if you do something to one side, you better do it to both sides. All right? Now, the 2/1 cancels out the 1/2, and you've got an x. Mission accomplished. You've solved. And on this side, 2 to the 2nd power is 4. And now we're done. So really simple. Now, what about this one here? We have x to the 2/3 power equals 4. Sounds really complicated. Do the 2/3 power? Not a problem. Multiplicative inverses to the rescue here. So we're going to take this side to the power of 3/2. Why? Because 3/2 is the inverse of 2/3. They will cancel each other out. But of course, if I take this side to the power of 3/2, I better do the same thing to the other side as well. These cancel out, the powers cancel out, and you get just an x, which is what you wanted. Now here, we have to use root power flip. Root power flip is the way we simplified numbers, just numbers, not letters, to fraction powers, to rational exponents. So the bottom number is the root, top number is the power, remember that? And so we're going to take the second root of 4, which is the square root of 4, and then take that result to the power of 3. And use parentheses for that. Don't do that, because that's wrong. Okay? All right, so what do we get? Well, start on the inside here. Square root of 4 is 2, and 2 to the 3rd power, 2 times 2 times 2 is 8, and we're done. All right, so we're solving equations now with rational powers in them. Okay, how about this one? X to the power of -3/5. Okay, well, not a problem. Just, do you know what the multiplicative inverse of -3/5 is? Yeah, it's -5/3. And if you do that to one side, you better do it to both sides. So this is going to be 8 to the power of -5/3 now. Okay, as long as you do it to both sides, it's balanced, it's good. The -5/3 cancels out the -3/5. They all go away, they become a 1. This becomes x to the 1st power, which is just x. This, on the other hand, you're going to have to use root power flip again. So it's the 3rd root of 8, to the power of 5. So put parentheses around it, go to the power of 5. And then there is a flip here, so to the power of -1, which is the flip. So let's see, 3rd root of 8 is 2. 2 to the 5th power, 2 times 2 times 2 times 2 times 2 is 32. And then that has to be flipped. You get 1/32. And we're done. So now you know how to get rid of rational exponents, fraction powers, using a multiplicative inverse. Now, how do you do this with radicals? Well, there is no way to do this with radicals, but we know how to rewrite radicals as fraction powers. Okay, rational exponents, in other words. So how do you do this problem right here? You realize that this, you root power flip it, or reverse root power flip. You write this as, this is the 2nd root of x to the 1st power. This is just x to the 1/2. And once you realize that, it's exactly the same problem that we had here. So you know it's going to be x equals 4. We don't have to do the problem over again because we already know that this is this. Now here, what is this? This is x to the 1/3. Okay, this is not the same as this, so we'll do this. Okay, and once you get here, what's the multiplicative inverse of 1/3? It's 3. So take this to the power of 3. It's actually 3/1. But you know what? If it's over 1, you don't need to write the over 1 part. So just to keep it simple, I'm going to write just x to the 3rd. Now the 3 cancels out the 1/3. So this becomes x to the 1st power. And 3 to the 3rd power, 3 times 3 times 3 is 27, and we are done. How about over here? We have a radical with, we have a 4th root with something inside. It's going to be x plus 2, this thing, to the power of 1/4. That's what it is. So a 1/2 power is a square root, a 1/3 power is a 3rd root, a 1/4 power is a 4th root. See how that works? And now that we know that this is a 1/4 power, we can use the multiplicative inverse of 1/4, which is 4, on both sides. These cancel out, right? The 4 cancels out the 1/4. And now all you have left here is just the x plus 2, and this side is 16. Okay, 2 times 2 times 2 times 2 is 16. And then you subtract 2 from both sides, you get x equals 14, and you're finished. Okay, so that's the idea behind multiplicative inverses and how they help you solve radical equations and rational exponent equations. Now let's do some more ambitious problems now, some more difficult problems. So what happens if you have a full-blown equation here, all right, with other stuff besides just a radical? These up here were like the simplest possible things. This has got a little more going on. This doesn't just have a radical, it's also got multiplication, it's also got subtraction, etc. How do you deal with this? Well, it says right here, the strategy is get the radical by itself. So in order to make this problem more like the easy ones that were here, you notice that these all have a radical that's got nothing else going on, just a radical. So here we have a radical, which is this part here, but we also have this 2 sitting out here. We also have this -4 sitting out here. We have to get rid of those things. So let's get rid of them. Now, what do you get rid of first? You always reverse PEMDAS here. We're going to get rid of the 4 by adding 4 to both -4. Get rid of the -4 by adding 4 to both sides. That takes care of that. And now we have this. And now we need to get rid of this 2 here. So how do you get rid of, this is 2 times the radical. So we'll do the opposite and we'll divide by 2 on both sides. And now we have this. Okay, and now this hopefully looks a lot more like the easy problems that we were doing here, these things, right? So we have a radical that's all by itself on the left side. Okay, and once we have that, we can do the thing that we did with the multiplicative inverses, which is we can write this as a fraction power now. So this is 6x minus 3 to which power? Well, it's a third root, so there's a 3 here. There's no power to worry about, so it's a 1/3 power. This side is still a 2. But now we know we can get rid of this 1/3 power if we use the multiplicative inverse of 1/3, which is 3, on both sides. That cancels out that, and we have 6x minus 3 on the left. 2 times 2 times 2 is 8 on the right, and now you have a very simple algebra 1 problem. Add 3 to both sides, 6x equals 11. Divide both sides by 6, you have 11 over 6 as your answer. So the strategy here is get the radical by itself. That's the big deal here. Get the radical by itself, and then after that, you can use the tricks that we learned in the beginning of the lesson here. Okay, let's try another one here. Now this one is not a radical, it's written as a power. Now, you notice what we did in the last problem here. We had a radical and we wrote it as a fraction power. Well, guess what? This one's done for us already. There's no radical to change into an exponential. It's already written as a rational exponent. It's already there. So all we have to do is get this part by itself. This is your radical part, by the way. Anytime you see a fraction power, that's a radical just in disguise. So when I say get the radical by itself, I mean get this by itself. So what do we have to get rid of here? Just the -1 rather. So add 1 both sides, and now you have this. And now the job is to get rid of this power, so we'll use the multiplicative inverse. The multiplicative inverse of 2 over 3 is 3 over 2, and we'll do that on both sides here. So this becomes 3n plus 2. And what's 1 to the power of 3 over 2? Well, the good news is that 1 to any power is still 1. So if you want to take the square root and then take the third power, you can, but it's just going to be a 1. So we get here, once again, algebra 1 simplicity here. Subtract 2 from both sides, divide by 3, and there's your answer. Okay, so solving exponential equations and radical equations, all with a simple multiplicative inverse. Okay, let's try this one here. So for this one, we want to get the radical part by itself, so subtract 6 from both sides. Okay, we get this. The next thing we have to do is get rid of this 3 here, so we'll divide both sides by 3, and we end up over here. Well, actually, let me kill 2 birds with 1 stone here. So instead of just copying this, let's change this into a 1/4 power, because that's what we're going to do next. So this becomes 2t plus 6 to the 1/4 equals, and this is going to be -2 right here. So we're here at that step that we know that we have to use the multiplicative inverse. We're going to take both sides to the power of 4. And these cancel out, and you get 2t plus 6 equals -2 to the 4th power. -2 times -2 times -2 times -2 is 16. Subtract 6 from both sides, you get 2t equals 10, t equals 5. And you box your answer. Now, I didn't make any algebraic mistakes. Everything looks fine, all right? But watch this. Check your answer. Take your 5, put it in for t, and see if it works. So this is 3 times the 4th root of 2t, and I'll put the t in here, which is 5, plus 6 has to equal 0. Does this work or not? Let's see. 2 times 5 is 10. And 10 plus 6 is 16, and the 4th root of 16 is 2. So this is 3 times 2, which is 6, plus 6 equals 0. So 6 plus 6 is 12. 12 equals 0 is the conclusion I'm getting, and I don't know about you, but that's pretty false, right? I don't know what you think, but 12 does not equal 0. So something's wrong. I got an answer here. I didn't make any mistakes, but I got an answer here that's false. And the problem here is that when you're doing these questions, it's possible, because you're taking both sides to an even power, that a negative is being disguised that would otherwise cause you to have no solution. So for all of these problems, and I should have done it here, but I wanted to, whenever you're doing any of these problems, you have to check your answer to see if it works. So this problem right here is actually no solution. This one does not work. What about this one here? Does -1/3 actually work in this problem? So let's do that. Let's check it. 3 times n, here's where the n is going to go, and n is -1/3, plus 2 to the power of 2/3 minus 1 has to equal 0. What's 3 times 1/3? Well, they're multiplicative inverses, so they cancel out. So all you get is -1 plus 2 to the 2/3 minus 1 equals 0. Well, -1 plus 2 is 1, so you get 1 to the 2/3 minus 1 equals 0. 1 to any power, including 2/3, is 1. So this is 1 minus 1 equals 0. 0 equals 0. Yes, it works. Okay? So this is true, all right? So you have to, for the homework tonight, you must, it's not optional, show the check for every one of your answers, because if you don't, you're going to get caught with problems that have bogus answers. So this is a requirement for this section, okay? And it's not an unusual requirement, because all of the logarithm stuff we're going to do next chapter, same thing. You have to check your answers. So there are such things as what are called extraneous solutions, and this is, you know, ostensibly, apparently, it looks like it's legit, but it's not. Okay, it's actually a bogus solution. All right, so what happens if you have more than one radical? Okay, so if you have more than one radical, like here you have two radicals in your equation, what do? Well, for the sake of simplicity, when you have, for the multiple radical questions, we're only going to use square roots. So you could do this with cube roots and fourth roots and fifth roots, but for our purposes for algebra 2, we're going to be using just square roots. So the question becomes, what do you do when you have more than one square root in the same equation? Well, if you notice that in the previous problems, our job was to get the radical by itself first, whether the radical is an actual radical symbol or the radical was a fraction power, which is also a radical, okay? Your fraction power or your radical has to be by itself before you can use the multiplicative inverse. Well, when you have more than one radical, you might say, well, how am I supposed to get the radical by itself? There's two of them, right? And here's what you're going to do, and it's in the notes here. As with single radicals, start by getting one of the radicals by itself on the left side. So get one of them by itself and let the other one be on the other side. So it doesn't matter which one I leave on the left and which one I move to the right. But since this one's already kind of furthest to the left, I'll leave this one alone and I'll move this one to the right. And how do I do that? I'll just subtract it from here and subtract it from here. I end up with this. So now I have this here. Okay, and that's step one. Step two, use the same method that we've been using with the multiplicative inverse. Now, this is a square root. So we could rewrite this as x to minus 12 to the 1/2 power equals 2 minus x to the 1/2 power. And the multiplicative inverse is the inverse of 2, which is, sorry, 1/2, which is 2 over 1. And take this side to the 2 over 1 as well. But you know what? Since we're only dealing with square roots, it's got to be a 2. So let's save that step and just square both sides. Okay? Because a square will cancel out a square root. Because a square root is a 1/2 power, and that's the multiplicative inverse of 1/2 is 2. So what I'm trying to say is get one of the square roots by itself, then square both sides. Okay, if you want the, you know, just tell me what to do version, it's get one of the radicals by itself, square both sides. Now this side very cleanly becomes x minus 12, okay, because the square root and the square cancel out. This side, on the other hand, is a binomial. There's two things here, and you can't just square a binomial by squaring this and squaring this. It doesn't work that way. You have to write it twice and FOIL it out, multiply it out, okay? So let's do that. What do we get? Let's distribute the 2. So this right here, x minus 12, let's make some room here. X minus 12 is the same. 2 times 2 is 4. 2 times negative radical x is negative 2 radical x. Okay, we're done with that. Now let's distribute this. Negative radical x times 2 is another negative 2 radical x. Negative radical x times negative radical x. The negatives cancel out, and radical x times radical x is x. We end up there. Now you might notice that we have some like terms here. These two are like terms, and when you add them together, you get negative 4 radical x. Okay, so let's keep simplifying. We got a 4. We got negative 4 radical x, and we got a plus x here. So once we've done that whole process, we have to go into phase 2. So I'm going to take this here, this whole thing, copy it, and stick it over here. Oops, not up there. Stick it over in the right-hand column here, paste it. And the second part now is you have an equation with only one radical. Get that radical by itself on the left side, and then you'll see what you have to do. So when you have two radicals like this, get one of the radicals by itself on the left, square both sides, and simplify. You'll get down to a single radical. This has to happen. Once you have one radical, it becomes like the problems that we did earlier. So let's keep simplifying here. Our job is to get this one lonely radical on the left side by itself. Now, I'm going to cheat because I have a computer here. I'm going to just grab this and flip it over to this side. All right. I'm going to move the equal sign over here. So I just flipped it around. At least now the radical's on the left. Now I have to get it by itself. So I need to get rid of this 4. So I'll subtract 4 from both sides. I also need to get rid of this x here, so I'm going to subtract this x from here. And if I subtract an x from one side, I have to do it from both sides. And let's see what happens here. These cancel out, and so do these. So I have negative 4 radical x on this side equals, these cancel out, and this becomes a negative 16. Now, trying to get the radical by itself, so I'll divide both sides by negative 4. And now I have radical x equals, and this becomes positive 4. At this point, you can see it's really simple now. Okay, this is x to the 1/2, so I'll take it to the power of 2 over 1. Another way to look at it is it's a square root, so I'm going to square it, and square root cancels the square, and we get x equals 16. Now that's my answer. However, I don't know if it's real or if it's bogus. The only way I know if this is a real answer is if I plug it into the original problem, all the way back to the beginning now, okay, and see if this works. So 16, plug it in for x here. 16 minus 12 is 4, so that makes this the square root of 4. Plus 16 goes into this x as well, square root of 16, equals 2. Okay? So what is the square root of 4? Square root of 4 is 2, plus the square root of 16, which is 4, equals 2. And this is 6, this is 2, and this whole thing is false. So actually, don't be fooled, this is a no solution. Okay, there is no number that works for both of these. Because we thought it was 16, turns out it's not. So you have to check your answers all the time, all right? If you don't do the check, if you leave off the checking of the answer, you won't get full credit for the homework. All right, what about if you have two radicals, but there's no extra number? Now, you notice over here, we had two radicals and something else. And this problem here at the bottom, same thing. We have two radicals and something else. But what if you just have two radicals and they're on opposite sides of the equal sign like this? This is your easiest possible problem right here. Because if you have a radical equal to a radical and there's nothing else messing things up, when you square both sides, it's going to actually get rid of all the radicals in one step. Okay? So the idea, remember, the steps are get one of the radicals by itself on the left. Check, already done. Second step is square both sides. Well, when you square this side, the radical goes away and becomes 2t minus 7. But then you're also going to square this side, and since there's only one term in here, there's no distributing to do. This just becomes t plus 2. And now you have an Algebra 1 question. So if you see one of these, rejoice, because it's an easy problem and you're going to get it done quickly. All right, let's just finish the Algebra 1 part here. We have a t on both sides of the equation. The smartest thing to do is to get rid of the smaller t, so we'll get rid of this one, which means we have to subtract t from both sides, like that. 2t minus t is t, minus 7 equals 2. Add 7 to both sides, t equals 9. We're done, but we still have to check our answer. So 2 times 9 is 18. 18 minus 7 is 11. So this becomes a square root of 11. I'm using the original problem, just the black stuff, not the red stuff. Equals, plug in a 9 here. 9 plus 2 is 11, so that's also square root of 11. And you see they check out, so this answer is valid. Okay, we're done. See you at the next video.
Check this.